Welcome back, Chemistry 11. Hopefully, you've had a chance to go and take a look at the videos from last day in regards to the distillation and as well as the chromatography. Okay, so hopefully you've had a chance to take a look and understand that mixtures can be separated due to the fact that they have unique characteristics. Now, one final thing I want to talk about is changes associated with matter. Now, again, you have been exposed to this back in grade 9, back in grade 10, about chemical change and physical change. So I'm not going to spend too much time on it. So a chemical change is where the substance undergoes a change in composition, resulting in the formation of a substance with different characteristics or different properties. Okay, now the way you can think of it for chemical change is something new produced. That's an easy way to sort of think about it. Is something new produced? Okay. Now, indicators of something new that is produced is where you get odors, you get bubble formation, you get a formation of solid when two liquids are mixed. But a chemical change is when you produce a substance that has new characteristics. A physical change is this change in the form, size, state of a substance without changing its chemical makeup. In this case, is something new produced? Okay, again, no new substance is produced. So for example, if we talked about the melting of water, where you go from ice to liquid to water to steam, even though you might have changed the phases, what happens is water is still H2O. It still has certain characteristics. So that is something that you have to think about between chemical and physical change. Is there something new produced? Now, the common question is some people might say, well, Mr. Chan, what about icing? You know, let's say you mix red food coloring with white icing, you get pink. All right, the key thing is something new produced? Has the red food coloring been changed in its chemical characteristics? Okay, now, when we talk about chemical or physical change, regardless of what happens, there's always going to be an energy change associated with matter. So there's always going to be energy either put in or taken out. Now, there are two terms that you should be familiar with. One of them is endothermic. Endothermic is when heat or energy is taken in from the surroundings. Therefore, the surroundings get colder. Like, for example, melting ice. When you take ice and ice is melting into your hands, going from solid to liquid, your hand gets colder. And that's because the ice is extracting heat or removing heat from your hand. And this is why your hand is getting colder. So that is called an endothermic reaction. An exothermic reaction is when heat or energy is released into the surroundings. Therefore, the surroundings get hotter. For example, like a burning candle. When you light a candle, the candle is, you feel the candle, it's getting warmer because that is an exothermic reaction. So what's happening is energy is being released, going into your hand. This is why it is getting warmer. Okay, now, something to think about here. So going back here, when you go from solid to liquid to gas, what's happening is that it's heat entering the system. So for ice to melt, to go from solid to liquid to gas, it's absorbing heat. That's an endothermic reaction. But going backwards, going from gas to liquid to solid, energy is released, and that would be an exothermic reaction. So this is why when you, let's say, put your hand over steam, why does it get really warm? Because the steam is condensing on your hand. It's going from gas to liquid. Well, let me go back up here. When you put your hand over steam, why does it get warm? Is because the steam, which is water, which is a gas, is condensing onto your hand, which is going from water, liquid. So what happens is that extra energy is released, and this is why your hand gets hotter. Something for you to think about, okay? Now, a couple of terminology that you might be not familiar with is chemical properties, okay, or chemical characteristics. So what is a chemical property? Is the ability of a substance to undergo chemical reactions and change into new substances. Will a metal react with, let's say, hydrochloric acid? Now, you might say, well, what's the difference between chemical change and chemical property? Now, a chemical change is an actual reaction, while chemical properties is the potential for reaction. An example would be like, I'm sure some of you have allergies. Some of you might say, oh, I am allergic to nuts. That would be like a chemical property. Your body will react. A chemical change would be like, I'm allergic to nuts. I get anaphylaxis and I need an EpiPen. That would be a chemical change because for you, when you eat the peanut, how it reacts to your body and you become anaphylactic and you need an EpiPen, that would be like a chemical change because that's the actual reaction. So chemical property would be like, I am allergic to peanuts. Chemical change would be like, I eat the peanut, my body becomes anaphylactic, and I need to use an EpiPen. A physical property is a property that can be found without creating a new substance. For example, density, color, hardness, melting temperature. These are things that you use on a substance without changing. Now, there are two general physical characteristics. One is intensive, and it does not depend on the amount of material present. And extensive depends on how much matter there is. Now, an example would be like you, whoever's watching this on video. An intensive property is you cannot change who your parents are, your biological parents. Your mother, your father, biological mother, biological father produced you. Your genetic code is an intensive property. You cannot change that. You can dye your hair, you can bleach your skin, you can change your name, you can get piercings, tattoos, whatever. That is an intensive property. You will never, ever be able to change that. An extensive property would be like how tall you are, how much do you weigh, what is your waistline? Those are all extensive property, okay? So that is the difference between intensive and extensive, okay? So in the case of water, water will boil at 100 degrees Celsius. It will freeze at 0 degrees Celsius. That will never change, okay? Extensive would be like, how much does a cup of water weigh? How much does a tub of water weigh? That will be extensive property. And the final thing is this, general laws for pure substances. Law of definite composition or definite proportions. Compounds have a definite ratio of elements. For example, H2O. Water is 2 hydrogens and 1 oxygen. Not 1.5 hydrogens, not 0.5 of an oxygen, but there is a definite ratio of 2 to 1. Now, if the ratio is different, let's say we have 1 oxygen, 1 hydrogen, then it will be something different. Or if we have 2 hydrogens and 2 oxygens, that's hydrogen peroxide, that has totally different characteristics. So compounds have a definite ratio of elements. For example, for me, my name is Mr. Chan, C-H-A-N. There is only one way to write it in the English language. Not C-H-E-N, not C-H-A-N-G, just C-H-A-N. And law of multiple proportions says that 2 or more different compounds can be made with different number of elements. So if you have a different ratio of elements, you get different characteristics. So for example, Fe2O3 is rust, while FeO is iron in food. Same elements, but different ratios. All right, that is it for today's lesson. Again, hopefully I will be assigning some homework in class, so please make sure to check the homework board in class for the homework for this unit. All right, folks, thank you very much. Have a good day. Bye-bye.